Okay, now it's working, I think. Can you still see my screen? Yeah? Yep. Okay. So the first thing that you need to decide when thinking about GUIs for research software is, well, whether does your research software needs a GUI at all? Is it something that will benefit from a GUI? Then you need to think on your users. Your users are the central part of a GUI. Actually, it's the U of the GUI. So it's the whole point of having a GUI. So you need to think whether they will benefit from having a GUI at all, whether they will use a GUI. And once you decide that their software needs a GUI, the user will benefit from a GUI. Well, you have to think on all the pros and cons of that. The pros are great. Probably you know most of them, but there is also a lot of drawbacks or a lot of effort involved that are the cons of developing a GUI. So we will go through this in this first session of the workshop. So you have all the information that you need to make a decision, an informed decision. So a graphical user interface is about the user. If they don't like using it, then the GUIs either are not needed at all, or it's badly done. So I hope that in Mark's talk, you will find out how to do it right. So it will tackle this second point about badly done. In this first talk, I hope that we will go through whether it is needed or not. So at the end of the day, you can create a piece of GUI that is actually useful and helpful for the users. So let's think about the types of research software that you can think about. This is a very broad classification that I made. It's probably not rigorous. There will be software that it doesn't fit in any of these categories, and there is software that will fit in several ones. But let's keep, for simplicity, let's assume that we have libraries that are toolkits. Essentially, they are meant to be used by other software. They are something that you need to you use by it requires some coding in order to use them, and they often include related to mathematical operations, for mathematical operation, data manipulation, accessing certain software or hardware. LAS libraries or LAPACK libraries, they all fall in this type of category. You don't create a GUI for them. They are just useful things to have around. Frameworks are more interesting for research in some ways. They are related to some particular field of knowledge, some particular area of knowledge. They, in addition of bringing code, bringing algorithm to the table, they often bring also domain-specific data, universal constants or material data, that sort of things that are very domain-specific. This is essential data, and they are used for very often for data analysis, to bring some high-level information out of the data that you have measured in the lab or that you are creating by other tools. Using them typically requires some coding, but the functions that they provide, the functionality that they provide is so high level that very often the layer of code that it requires is very thin. So it shouldn't be too hard to transform them or part of them into a full applications, either command line applications or graphical user interfaces applications or GUI applications. The next one are command line interface applications. We are familiar with many of these, Git and Docker, you probably know them. They are often domain-specific. Domain-specific tools are often HPC oriented, so pretty much everything that you run in an HPC, in a supercomputer, is a command line tool, but they could be pretty much any compile code. It's a command line interface application. Others are used to facilitate research, to enable research, like Docker and Git. They are not really specific for research, but they are extremely helpful for researchers to keep track of their work of Docker. And they are all command line applications. They do not require coding, but require the terminal, using the terminal, which for some people might be a barrier. And finally, we have applications that are purely GUI. The whole point of the application is to have the GUI. Web applications fall in this category. I don't know, here I put a couple of them. Integrated development environments are GUIs, Spider by Visual Studio. So the nice thing about the applications of this kind is that they can reach everyone. Of course, if it is an application about molecular dynamics, well, it doesn't matter whether it's a GUI or not. You will, if you are not in that field, you will not be able to use it much very efficiently. But you can use it. You can interact with it, which is nice. The barrier for adopting that tool is often much lower. So when we think about which of these actually can benefit from a GUI, whether it's something that we should be investing time on it, in the end, the groups that that do not have a GUI and that could benefit from one are frameworks and command line interface. The libraries are great, and there are fantastic libraries for research, but they are so low level that the users do not normally interact with them directly. They do not need a graphical interface to interact with them. They are employed by frameworks or CLI applications. So we don't need to worry about if the software that we are developing is a library, we don't need to worry about that. We can move on and work on different things. If it is frameworks or CLI applications, then we have to think about that. One important thing about graphical user interface is that some people sometimes do not, are worried about is that when you create a GUI, you don't need to create a GUI to cover all the functionality of the software. Most frameworks and more command line applications have a lot of functionality, a lot of things that they can do. You don't need to provide a GUI for all of them. You need to provide a GUI for those things that are more useful for the user. And that helps you start small, creating the application bottom up with small increments, small new features, additions, see what people say about the application, and then keep adding new things as they are required. But thinking on a complex framework, for example, AstroPy, for example, it's huge. You cannot provide a GUI to start with for that. It will be discouraging for everyone to try to provide something that covers everything that framework can do. So once we have decided, so now it's a point of reflection. You have to think, sit down and think about your software. Okay, is it something that will fit into a GUI? It will not. What sort of functionality could be useful? And for this, we need to answer, well, who are going to be our users? And users come in all shapes, sizes, and shapes. And they, even if they are they are using the same software, the same piece of software, they will use it in a different way, depending on their specific goal when using the application, depending on their expertise of using the software. Here, the pictures here just show an example of a mobile phone. It's the baby, which uses a mobile phone in a very specific way. Probably not in the intended way for those that designed the phone in the first place. Then you had people who use it mostly for taking pictures or sharing them in the social networks. You have someone who actually use the phone for calling other people, which probably are the less common use nowadays. But it is there. So the device is the same, but it is used in a very different ways. The same applies to software. So it's important that you know your users. There are many types of users. Here's an example, a few examples of different users in academic users, let's say. We have a postdoc, Anna, who likes to have things done. We have another postdoc, but this one is more on the HPC side and not so much on the experimental part. We have the professor, Elsa, who, well, essentially has negative time, so she needs things done for yesterday. PhD students, another postdoc, more related with outreach, a technician. All of them use software all the time for different purposes. They will want different things from the software. Who is your software oriented to? Who is going to be your main users, or who is going to benefit from your software? Is it going to be a postdoc with a lot of experience in the field that might not know that particular software, but know all the concepts and all the information related to that tool? Is it a PhD student who has just joined the team and really have no idea what's going on? but it has a lot of enthusiasm, but doesn't know many of the concepts or the naming conventions or the things that are important. Is your software meant to be used to acquire data from a experimental setup? So it will be oriented towards a technician that needs to deal with users that have problems with the software. So in the case, there will be a super user, so the technician who knows everything about the software, but then lower level users that will need to interact in a different way with the same software. So think on the specific software of the specific needs of your users. Ask them. The next thing about the research software is that very often research software is a very niche field. So you can do a very complex user research, but the simplest thing is ask them. Gather the people that you think will be using your software and ask them what things, what do you want to accomplish. Try to ask people with different degrees of expertise, and ask them as people that is different from you, because you might use your software, you will use your software, but you will know more about your software than anyone else. You are not really a good example of who are going to be your users. So ask other people from other fields. If it is a general purpose software, something that extends to that is not very specific for your research area. And also think those that are not users yet, but that could become. This could be, for example, master students, PhD students, people who have no idea, no previous idea on this software and will need to adopt it. What sort of things they will find helpful? Do they need some sort of a tutorial to help to be on board? Do they need some sort of wizard, this step-by-step process to have things done? Ask them what sort of things they will find useful in your software. And when they start using the software, what barriers or challenges are they facing that is preventing them to achieve their goals? And if you already have a GUI, because it was a preliminary version, some of you, I think, that mentioned that you have a 90s looking software that you want to improve. I think in that case, it was more improving about the look and feel rather than the actual functionality, but there is already a GUI. Fine. Ask your users how do they see the software, the GUI, to improve, what things they would like to see in the new version. So you can create the new version based on the feedback of your users. So this is well, I'm not going to go through in detail through this. There's a lot of resources out there on how to gather information of users in relation to research software. I don't remember if Mark mentioned something, but yeah, there's a couple of links down there that you can check. One of the simplest way of thinking about your users is generating these user personas, which are examples of semi-fictional characters, the postdoc, the PhD, etc. Specific people with specific examples that you can see here. This is a specific postdoc working in a fixed term contract in a basic research group, has teaching duties. So this gives you an idea of not just what's the expertise of the person, but also the context this person is working on. If it is a fixed term contract and has other duties, probably she doesn't have much time. So it will need some that will be one of the barriers probably later on. So what they want to achieve and what are the barriers, the challenges that they are facing and how they are dealing with that. So this is sort of a description of specific use cases will help you to shape the creation of the GUI. But it's a lot about reflection and asking users what they want. Don't be shy about asking users. As Mark will mention, users also lie because sometimes they don't know what they want, but I will leave that to him. So we are going to discuss one particular example. Do you all know Git? Raise your hand if you have never heard of Git at all. Okay, you all know about Git. Fine. So for Git, we have the command line interface that we can use. Git whatever. It's very well known. You can use Git very often integrated with some IDEs. You have an interface for Git in PyCharm, in Visual Studio, and pretty much all big IDEs have some sort of interface for Git. And you also have a standalone GUI apps to deal with deal with Git, to make commits, to push things into a repository, bring them back. So, and these are designed specifically for Git, so they are not integrated somewhere else. So, how many of you? Can I make a poll out of the blue? Okay, I'm going to just raise hand. So, raise your hand if you use Git in the command line only. If you have never ever used Git in any of the other two options. Okay, there's someone who only uses Git in the command line. Perfect. Now, raise your hand if you use Git for some specific functionality, if you use the command line, and for other functionality, you use one of the GUI versions, either integrated in the IDE or as a standard application. Depending on what you do, you use one or the other. Yep, that's what I thought. So yeah, I think that this is an example of a classical example of a tool that it's useful, that some people will. Oh, and finally, is there someone who only exclusively uses Git in the with a graphical user interface and no other way? Okay, a couple of people. Good. So we have the three options, but the majority use Git in the command line for some things, and use Git within the GUI for other tasks. So this is an example of what I said before. When you create a GUI to solve some limitations or to expand the capabilities of some command line interface application or framework, you don't need to code to implement every functionality. You need to learn what users want to use as a graphical user interface, in a graphical user interface, and code those. There's no point on adding everything if people is going to be using creating commits or adding things in the command line or cherry picking in the command line. That's probably an advanced use that just someone that some people will use the command line anyway. So don't bother to implement those in the GUI. But for example, I guess that my particular use case when using a GUI for Git is when merging branches and there are conflicts. It's way easier to deal with conflicts, at least for me, when you have a graphical interfaces and you can choose which things you want to pick from all the conflicts that you have. That's a nice particular example of why of using a GUI for one particular thing, but then I use for adding things and making commits. I use the command line. It's easier for me and faster. You will have other use cases. The same that applies to Git that we have just seen for Git will apply to your software. Think what things you will like to implement as a GUI, because people will use those as a GUI. Things which ones will be better suited to use just in the command line or when using your software as a library, as something that you can import in other software and use it there. Because it's not exclusive. Adding a GUI doesn't mean that you cannot use the software in other means, by other ways. So now we come to the meat of the problem. So let's say we have a software that we know we want a GUI for it. We have our users and we have talked to them which things they find harder to use of the software and which things will be great to have a GUI for. Now you have to think about all that comes with it, the good and the bad. So let's go through it. So probably the first thing that comes to your mind when implementing a GUI, and you mentioned some of this during the introductions, is accessibility, to making the software accessible to everyone. Free of use, I think that someone mentioned. But it's not the only one. It's also an aspect on usability, responsibility, and impact. Let's go through this. The accessibility part separates the user from the developer. So even if it is you are the user, you will interact with the software in different ways when you are developing it than when you are using the software. So that helps this separation of concerns, which is common all across the software development, will help to tailor the needs of each of these interfaces appropriately to the different use cases. Accounts for users' needs. So you can, in a GUI, you can take into account things like disabilities, provide some sort of high contrast or some extra tools to help people with disability interact with the software. You can easily or relatively easily change the language of the software. Programming languages are pretty much all English, but and that's common, that's fine. But if the software is not aimed to researchers only, it might be useful, or it will be useful to provide a means to of having the software in their own language. Again, is reducing the barrier for adoption of the tools. And the main thing maybe is that the people using the software doesn't need to have any idea about programming. You can, people that no coders can use it, no experts in that field. If it's a general purpose software, can use it. And if the software allows for it, even students or children, let's imagine you have some sort of tool to manipulate a robotic arm in a science fair, that you will want students and children to play with it, then you cannot use a coding interface. You cannot use a command line interface. You need to use something more user-friendly. Usability is another thing. This is a big thing. There are books and web pages about usability. I've just picked 3 specific aspects that I think are particularly interesting, but there are many aspects related to usability of software in general and web interfaces. First one is learnability. So it reduces the learning curve and the time it takes to become proficient with the software. If you have a well-designed, let's not say a GUI, because a GUI could be horrible, but a well-designed GUI reduces the learning curve of the people trying to interact with the software because of all these visual layout of things. Efficiency, the user can focus on providing the research inputs to the software and getting the outputs and studying the outputs, not on the technical details of what happens in between, or whether if it's a framework that you need to code so a little bit to implement the things. Well, am I using the correct keyword? Is it a comma? Let's check the documentation. Those are technical details that are in the way of getting results out of your research. You don't want to do that. So a good GUI improves the efficiency of the user when interacting with the software. And finally, the memorability. Visual things, an image, it's worth 1,000 words. So it's way easier for people that has used the software, has not used it then for a long while, comes back to get used again the software, to remember how things were done, because it's that's visual memory. It's very powerful, and even if it gets rusty, it gets up to speed very fast. It's like driving or playing a musical instrument. You don't fully forget unless it has been many years, but then they will change the interface anyway. So you don't need to worry about that. You don't fully lose that ability. So when you come back, it's easier for you to adopt that. Reproducibility, this one is an interesting one. So well-designed GUI offers less scope for misusing functionality. So the user is not necessarily guided, that will be a wizard, but it is offered or highlighted only those things that are relevant for the user in one particular time. So, for example, let's think on Office, on Word or Excel, something like that. Unless you select some text, for example, you don't need the buttons for bold, italics, something like that shouldn't be highlighted, because you cannot use those unless you have the text selected. So why allowing the user to click something or trying to click something that will do nothing? This is the same with research software. Offer the users those or enable those functionality that is relevant on one particular time, depending on what the user is making. That gives the user less scope for misusing the software. You can implement validation checks at user input. So you can implement validation checks, of course, in when you are coding. But validation checks in the GUI, typically it happens, those validations takes place as the user inputs the value. So if you are having one particular field that should be an integer and you put a string, immediately the graphical user interface will tell you this is wrong. It will correct it or will not let you put that value. Whereas if you have if you are using the software in a command line or as a framework, you need to run the software, and at some point in this run, hopefully at the very beginning, but sometimes that's not the case, things will fail miserably, or there will be some sort of warning saying this has not the correct type or the correct value. So that validation can be implemented very easily in the GUI and inform the user when things are right or wrong, or with how they need to be corrected. You can also include these hints here and there to help the user do things right. And the fact that you have very often have all the or most of the input values as in a sort of dashboard that you can see, it's very explicit on what the software is taking as input. You will have the output later on, how you can change things, what input you can change. So they are explicit and visually accessible. Now, the reproducibility is a double-edged sword, because it's not something that you can, when you run a particular piece of software through a GUI, it's not something that you can capture easily in sort of pipeline. The user will click buttons in the order they want. They might move the screen somewhere else. So it's not something you can, for example, put in a container and distribute and say, well, if you run this in this way, it will produce the same outputs. Well, no, because you cannot ship the user interaction in the same way that you ship some sort of pipeline file. So the GUI has to be really, really well designed to make sure that reproducibility really is reproducible and not some sort of mess that the user has to later on to explain in some sort of external files. And okay, well, go here, click here, then move here, then drag this screen here to avoid hiding somewhere else. That's harder to reproduce. So this is, as I said, some sort of double-edged sword. And the final thing that is the good thing about GUIs, and it's sometimes not value enough, is the impact of having a GUI. So all the previous things, at the end, one of the results that they have is that you increase the user base of the software. And that means, that has several implications. The first, that if we are talking about an open source software, for example, having more users means that you increase the potential pool of new contributors, help people that will provide back to the software, that will help you find bugs, add functionality, help you with the documentation, clarifying documentation. So it's really good to have a big user base. If the software is properly prepared for it, you can get citations, which is good for academic point of view. And it increases the visibility. More user base means more people using the software, but also more potential routes for collaboration, establishing collaboration, research collaborations with people all around the world. And that's something that it's a good selling point for PIs, for example. If you try to convince your PIs of why investing time on a GUI, well, tell them that high more visibility will enable more routes for getting grants, collaborating with other people. And well, although it's not often done that much, it's also a good visibility for RSCs as long as they are mentioned somewhere that they contributed to this particular tool. Very often, well, if you are a researcher postdoc, you will appear in publications and being in different parts related with software. But RSCs, if it is someone that you have hired to do the work, we will very often disappear somewhere and we will never be mentioned. It will be helpful and nice if we are actually mentioned as contributors to these tools, but that's politics, let's say. So far, so good. Then the bright side of having a GUI. Now, the dark side. There's also a dark side. This comes, all these nice things come with a price that you need to be ready to pay. And I mean, I guess that for many of you, this is what has prevented you to get into developing a GUI to start with. So the most obvious one is time. Adding a GUI takes time, takes a lot of time. It often takes way more time than you were expecting to invest on this. It's time developing things, but it's time creating tests for for the code that you have created, and it's time that required to create some sort of deployment pipeline that people can install. If very often it's easy to distribute some sort of library or some sort of base code, but if you distribute so a tool that has a graphical user interface, you need to package in a certain way, make sure that those graphic libraries are well accepted by the operating system, which can be a bit picky when graphics, when we come down to graphics. So it's all about, it will take time, and time is more costs. It will be more expensive. And more time also delays the delivery of the product. If this is some sort of, you are an RC and you are working for a client who is paying you to develop this tool, it will take more time for them to have the tool. And they need to know that tool, to know that if they want a GUI, it won't happen over the next month. It might take 2 or 3 months more than they were expecting. And if this is to get funding, it will take more time for the tool to be ready to be shown to stakeholders. Or if you are writing your thesis, it will take more time. So having the thesis ready might take longer. So it's all about time. If you are thinking about implementing a GUI, be ready to invest time and account for it when you think when this will be finished. Complexity. Having a GUI at the end is adding more code to your software. More code means more things you have to provide tests for. They will have bugs for sure, because every piece of code will have bugs, and the more code you have, the more bugs you have. And it typically the graphical user interface will depend on other libraries, external libraries, that you don't have any control over them, and these will bring their own complexities, their own bugs, their own backwards compatibility issues, and breaking the API, and then you have to go back and revert to previous versions, and that's a pain, to be honest. And yeah, a GUI application is very different than your typical research software. The architecture of the software is going to change dramatically when you have to consider that you need something that the user can interact with and that it's running there all the time. Very often, applications are linear. You launch them, reading the input values from whatever you want, input files or some input parameters, and they run with those, and you get at the end a result, and there you go, beginning, end. Graphical interfaces are very different. They are running all the time, and to allow the user to interact with them, we will talk about this in detail tomorrow. You need different ways, to learn different ways on to keep the separation of concerns. You will need to learn about multi-threading and to make the application fluid, and to accommodate user interaction. This is all about a new level of complexity on top of whatever you already have in your own application. New skills, coding skills, learning new libraries or new Git toolkits is relatively often, but it's often done regardless of whether you have a GUI or not. But very often also you need to learn different programming language. Some of the GUIs, common GUIs, let you, it's not compulsory, but they let you create the graphical interface with some sort of declarative language rather than whatever you are using, C or Python or whatever. There's this separation of languages. You can see it very clearly in the web stack. So you have CSS, you have HTML that are used for something entirely different to JavaScript. So you have 3 different languages to create one single application. What else? You will need to learn about these new software architectures. You need to invest time knowing finding out how to use them. You need to learn new ways of testing your GUIs. These are things we'll talk about tomorrow. And new ways of development paradigms like event-driven programming, something again that we will talk about tomorrow. This is not something that you come across normally when you develop research software, and are things that are necessary, are essential when you want to deal with GUIs, especially desktop. I think that things are more fluid, or those are hidden behind under the hood when you develop web applications, I think. But when you develop desktop applications, you do need to learn all of this to make a well-designed GUI. So, and finally, well, for a command line interface, you don't need to be very creative, but if you want to do especially a professionally designed graphical user interfaces, so if you want to invest money on this, you will need a designer. The designer is not just someone who knows about colors and shapes and things like that. They very often know about the psychology of the users, how to best interact with them. I think Mark will talk more about this. How to what's the property layout to maximize efficiency, where things should be, or how things should be arranged around some sort of central widget to exploit the user experiences. Is the usual thing. Well, nowadays no one knows what a floppy disk is, but the floppy disk icon is still the one that you click when you want to save something. People is familiar with that. Where it comes from doesn't matter, but if you put some sort of a strange device as the icon to save, people will not know what they want, what that icon is about. And of course, a designer hopefully will have a good taste for creating pleasing look and feel, combining colors appropriately, will deal with proportions and distribution of widgets and that sort of things. In most cases, you will not need a designer. You can learn some of these features up to enough to make a good enough application, GUI application. But in some cases, as I said, especially if you want something that is professional looking and that you need to commercialize, for example, if you want to have a software you want to commercialize, it might be worth for you to invest money in getting someone that really knows, that has been trained with these things in mind. So these are the last few points that I want to make in relation to this first talk of the workshop. First, not all software needs a GUI. You need to think what your software is, what you want to achieve with it, and what your users will want out of the software, whether it's something useful for them. Having a GUI doesn't exclude using the software in a different way. An example of that is Git. You can use Git as a command line. You can use Git in a GUI. You can use Git only with a GUI. So do not think that you have to implement every single functionality in the GUI, at least not to start with, because it's absolutely fine if other functionalities still get to be used in the command line or or in a piece of code. Second part, very important, know your users. In research software, it's relatively easy to ask them what they want, how they are going to interact with the software, what they are expecting out of the software. Count with them with designing the GUI. It will help you a lot to have their input when designing the software and make it interactive. So create something, draw something, go back to them. This is what you think will be useful. Yeah, well, no, this is not comfortable. It will be a several step process. Mark will talk about that. And yeah, think about all the pros and cons. It comes with a lot of benefits, having a GUI, but also with a lot of effort, a lot of work, a lot of extra money, extra time. And sometimes in research, at the end, that's the main barrier, whether you have time and money to do something. The skills can be learned. but sometimes money and time, it's just not there, no matter what you do. So you will need to think about this. If you need to convince the relevant people in charge that it is worth this, the time and the effort. And yeah, that's pretty much it. Oh, okay. I'm going to. So, do you have any question about this first part of the workshop? Yep. Yes, Kasim.
Hi. Thanks for that. That was brilliant. Really informative and yeah, really useful. I was just wondering about your, you had 4 different types of software, and in term or not even software, but just utilities, I suppose. My question is, sometimes you're just making a simple tool, right? You've got a script and you just need an interface for that, say, one function. And that brings up the question of the definition of a GUI. So is that graphical user interface something that would apply to just that single sort of function, or is that something different?
Well, I think that if that function is something that a user without any well, either time or experience coding will need to use, a GUI will definitely be useful for it. There is one thing that I will talk about tomorrow, is that when you have simple or relatively simple scripts or command line interfaces, there are, in Python, there are very simple ways of creating a GUI with one line of code. And I will show you about this tomorrow. Essentially, it reads what sort of information that function that you are executing requires as input. If it requires 3 parameters, whether they are integers, a string, or a path to a particular file or something else, it will read that information, and it will create a GUI with a lot of default decisions on how things are laid out and with minimal effort from your side. It will create this GUI for you. But even I think that anything, it doesn't matter if it is a function or a whole framework. Actually, it's good if you start with a function and then you add more things. If you think that a user will benefit from having a GUI, then you should add a GUI. You don't seem convinced.
No, that's fine. No, that was excellent. I just was wondering, when you think of a GUI, you mentioned Microsoft Word, that has quite a lot of complex, functionality. There's a lot of buttons, there's a lot of different things you can do in it. On the other hand, there is sometimes, you might have a script that just does one thing, and you just need something very simple, like a shell almost, for that script. I was just wondering if we were using term GUI to apply to both.
I think it's fine. I don't think that you need a complex application to consider it as worth of a GUI. Some things simple are also fine to include a GUI for. So it's even better to start with, because creating something as complex as Word, a GUI as complex as Word, takes years, if not decades. Recent software is often way simpler in terms of the options. So I think it's fine. Yeah, I will add a GUI to a simple tool if it's going to benefit the user in the end. And it is a GUI. You can call it a GUI if it is a graphical user interface. And I have a mixture of people asking in the chat and the questions. So I'm going to Matthew, and then I will check the Python.
I'll just say,
so Matthew, yeah.
I just want to say that the other month I wrote a GUI for a one-liner function that I had written, and I've done, got extra people using it because they're afraid of the command line. So it's a GUI. All it does is prints the standard output to a window that I made, and you've got a button to load a file, and you press go, and then it works. So I'd call it a GUI. It took me like 2 weeks to make it work, but
no, but it's a GUI. It's a perfectly fine GUI that does what it should, which is make your life easier when interacting with the software. Someone has mentioned, Pen has mentioned a Python tool called GUI. I will talk specifically about GUI tomorrow because of that, because how simple it is to transform a command line interface into a GUI interface with just one line of code. Yeah, the rest are comments, quite nice comments, but yeah. Any more questions? Getting, you still have your hand raised. Is it from before, or do you actually have? Okay, fine. Great. Okay, so I think we do have a break now before Mark's talk. Let me check the, well, I'm going to stop the recording.